Okay, Algebra 2, we are talking about synthetic division and direct substitution. This is pretty much the exact same thing we did yesterday. It's just we are determining if something is a root or a zero, or if it's a factor. Now, all of that means the same thing. So something we need to make sure we understand is that when it says like x minus b is a factor, or x minus 2, x plus 5, something like that, x minus b is the same thing as saying b is a zero, or a root, or a x-intercept. Those are the same things. So in this first example, we're going to look at x equals 3 would be the same thing as x minus 3 as a factor. Okay? And it is a 0 if the remainder is 0 for synthetic division. So there's two ways you can go about these problems. The way I probably prefer is synthetic division because it goes quick, it's easier. But substitution works too, and that's something you are probably pretty familiar with. Okay, so let's look at both ways. So if this is x equals 3, just like we did yesterday, that's the one that goes in the box. That's the one we multiply by each time. And we're putting our coefficients into order. So 2, we're missing x to the third, so that's 0. And then 8, 5, and 7. So I bring down the leading coefficient, and now we're ready to go. So multiply, 2 times 3 is 6, add down, that's 6. 6 times 3 is 18, add down, that's 26. 26 times 3, that's 78. Add down, that's 83. 83 times 3, let's do that in the calculator. That's 249. And so 249 plus 7 is 256. Not a remainder of 0. So as I'm evaluating, my final answer would be, this is the constant, so this is 26x, so this is 6x squared, so this is 2x to the third. Plus the remainder, 256 over, since it was x equals 3, it's x minus 3 as the divisor. Okay, or the divisor, I was right. Okay, so if we were determining if it was a factor or not, we would say no because this is not 0. Okay, so let's do the exact same thing, checking this, x equals 3. So direct substitution just literally means substitute in anywhere there's an x to see if this is a 0. Okay, we're evaluating by plugging in for x. So y equals 2 times 3 to the 4th power plus 8 times 3 squared plus 5 times 3 plus 7. Okay, so now we go ahead and multiply that out. So that's 2 times 81 plus 8 times 9 plus 15 plus 7. 2 times 81, that's 162. That's 72 plus 15 plus 7. And I'm going to add that in my calculator because I don't want to think too much. 162 plus 72 plus 15 plus 7. It's 256, which is what we got last time. So since that is 256 for y, the x equals 3 is not a 0. But it didn't ask that. It just said to evaluate. So when you evaluate, you're really checking to see if this is a factor or not, or a 0. So since that was a non-zero number, that is not a factor or not a 0. Same thing here. Not a 0. And we're not saying that's not a 0, but x equals 3 or x minus 3 is not a factor, or x equals 3 is not a 0, and so on. So really I should be saying this is not a 0. Okay? So let's test this out on a couple of these. We're going to do one of each. I'll do synthetic division for the top, direct substitution for the bottom. Okay? So since this is x plus 1 equals 0 means the x value I'm using is -1. So -1 is the one that goes in the box. Then I fill in the numbers. So 2, -1, 2, and 5. Bring down the leading coefficient, and we're off to the races. So 2 times -1 is -2. That gives me -3. Multiply. The -3 times -1 is +3. Add those, that's 5. 5 times -1 is -5, and what do you know? Remainder of 0. So since it's a remainder of 0, that means that that number is a 0 that we tried, or that factor is a factor. That polynomial, that binomial is a factor. So I evaluated to get 2x squared minus 3x plus 5. That's the evaluated version. And then we can now say x equals -1 is a 0, or is a solution. Or you can say x plus 1 is a factor. Both of those mean the same thing. So in this case, I want to answer the question. So the question in this case, determine if the following are factors. So I just need the bottom one, so I can kind of get rid of this top one. X plus 1 is a factor. There we go. So let's try it again. This time we're going to do direct substitution. So this time the direct substitution, we're going to use this number. So x equals -2 is my number. So direct substitution means plug it in for x. 15 times -2 cubed minus 32 times -2 squared plus 3 times -2 plus 2. Now we do our magic. So -2 cubed is -8. -32 times 4 plus +3 times -2 is -6 plus 2. And so let's take care of these numbers. 15 times 8, 120. Oops. And -32 times 4. 120 and 128. So -120 and -128 minus 6 plus 2. And so when we add those together, -120 minus 128 minus 6 plus 2 equals -252. So since that is not 0, that means that x plus 2 is not a factor for this polynomial. The only way it would be is if we got 0 here, which we did not. Okay? So let's go ahead and go to the back side. We're still doing the same thing, but look at the wording. It says, determine if the following is a root of the polynomial. That is asking the exact same question. There's no different there. So you can use direct substitution or use synthetic division. I'm going to use synthetic division for both of these numbers. Just because, again, it goes quicker. It's easier. I am always looking to get through things quickly with less work. So take that 15 down, and now we're ready to go. 15 times 1 is 15. Add, that's -17. -17 times 1 is -17. That's -14. -14 times 1 is -14. That gives us -12. So the fact that this is not 0 means that 1 is not a root. So we move on to the next one. So -1/5 is my number this time. Again, don't be intimidated by these fractions. If the fraction is a 0, it's going to be kind of easy to plug into. So like this case, 15 times 1/5 is just negative 3. So negative 32 plus negative 3 is negative 35. What's 1/5 of 35? That's positive 7. 7 plus 3 is 10. 10 times negative 1/5 is negative 2. And what do you know? Remainder of 0. And so our evaluated polynomial would be 15x squared minus 35x plus 10 with no remainder. But what that means with 0 over here, that means negative 1/5 is a root. And that's what we were looking for. Okay? So let's go down here. I'll go ahead and do the first one with synthetic, and then whatever's left I'll do with substitution, just to kind of, actually I'll start with substitution, just to mix it up. So this is the exact same thing though. Determine what the roots are. But then it says if it is a root, write it in the depressed polynomial. So the depressed polynomial is like what I wrote up here. If I wrote this as a depressed polynomial for this one over here, this one didn't work, so that throws out. Over here, though, I've got 15x squared minus 35x plus 10. That would be part of our polynomial. And then this one is a factor, okay? But I can't write x plus 1/5. I've got to slide that up like we've been doing in class, 5x plus 1. And so that would be our depressed polynomial, written out in parentheses, okay? So that's what we're doing down here. So in this case, synthetic division kind of lends itself nicely to that, because when you get down to your answer, what you have left is your depressed polynomial. So 1, negative 7, negative 6. So I'm going to do synthetic division through the whole thing here. So here we go. 2 times negative 1 is negative 2. That's negative 1. Negative times negative is positive 1. That's negative 6. Negative 6 times negative 1 is positive 6. So that one worked. Okay? So what that means is this x value, negative 1, works. So x plus 1 would be the factor. So that's one of my factors that I'm going to use. And what I have left is 2x squared minus 1x minus 6. That's the new polynomial that I have. It's been depressed from 3 to 2 as the biggest power. Third power here, depressed to 2 power here. And so the next one I use is 1. So 1 is my number in here. 2, negative 1, negative 6. Bring down the 2, and let's go. 2 times 1 is 2, that's positive 1. 1 times 1 is 1, that's negative 5. Since it's not a 0, I throw this one out. Okay? 1 is not going to work. So I've tried 2 with the same one. 2 in the box, 2, negative 1, negative 6. Let's see if that works. 2 times 2 is 4. That gives me 3. 3 times 2 is 6. And what do you know? Remainder of 0. So what I have now, since 2 worked, x minus 2 is the factor. And whatever's left is probably going to be our last factor. So right here, 2x plus 3 is our other factor. So using these 3, I now have the depressed polynomial that I write as a one big parentheses polynomial. So what I have left is x plus 1, that was the first factor I found. X minus 2, that was the second one. And then what I had left was 2x plus 3. And that is my final depressed polynomial answer. The factors, negative 1, positive 2, and then if I did the math, negative 3 over 2. There we go. So again, we're going to be practicing this the rest of the week, and then again, it'll make more sense the more practice we get with this stuff, as well as in behavior. Peace.